Okay, so let's go to the next one. Now here we have num1 not equal to num2 multiplied by 2 minus 2. So let's replace these variables num1, num2 with their values. So num1 is actually 75, num2 is 40. Yes, and then we have multiplied by 2 minus 2 not equal to. So this is the expression now after substituting the variables with its values. Okay, so now we have to actually solve this. Now on the left side we have just one number, so there is nothing to evaluate any further. But on this side there is an expression like multiplied by 2 and minus 2, so we have to solve this. Solving this, first you have to do the multiplication because multiplication has higher priority over minus. So 40 into 2 has to be done first, which is 80. 80, and then we have this minus 2 coming here and 75. So now the expression is after multiplying this, the results is this now. Now we have to solve 80 minus 2, that is 78. Then we have not equal to 75, this one not equal to 78. So 75 not equal to 78, that is true, no? 75 is not equal to 78. This is a statement, right? So in condition what you are checking is this statement correct or false? When you say 75 not equal to 78, that's a true statement. Therefore, this evaluates to a true. Okay, then we go to the S1, which is 200 minus num1, num2, these two variables. Okay, so let's see, replace those variables first. Num1 is 75, num2 is 40. Okay, and the rest of the condition 200 minus multiplied by 2 less than, and we have this 40, then into 3 minus 2. So now we have this expression. So in this expression, we have to first evaluate the brackets on the right side if you are going to. So let's first finish the left side and come. In the left side, we have a minus and a multiplication. Left side of the relational operator, okay? We have a minus and a multiplication. We have to first do the multiplication because multiplication has higher priority over minus. So 75 into 2 is 150, then 200 minus 150, which is the result of this, and the rest of the conditions as that. Okay, now we have to solve 200 minus 150, which comes to evaluates to 50 less than the rest of this. Okay, so now the left side is evaluated to a single figure. Now we solve the right side. So when you're solving the right side, we have to first work out the brackets because brackets have higher priority over multiplication. So we have to first do this. So then 3 minus 2 is 1. Okay, we write the rest of the condition, that is this 50 here less than 40 into this evaluated to 1. So now we have this condition 40 into 1. So let's solve that also. 40 into 1 is basically 40, and then we have this. So now this expression is finally evaluates to 50 less than 40. That is false. 50 is a bigger number than 40. So when you say 50 is less than 40, it is considered false. Okay, so this evaluates to false. Remember that. Okay, so this expression evaluates to false. Next one, word 1 not equal to less. Less is a alphanumeric constant. Word 1 is a variable because there is no double quotes for this. So word 1 we have to take from this. This we are actually referring to this variable. So this variable also contains the word less. So we'll replace word 1 with the word less. So less, and then we have not equal to less. So this expression evaluates to this one. So now what we are comparing is the word less not equal to the word less. No, they are equal. No? So if you say less is not equal to less, it's false. The statement what you're saying is false. If we put equal here, then it will be true. But since we are saying it's not equal, then this is false because less is equal to less. So if you say less is not equal to less, then that statement is false. Okay, so this evaluates word 1 not equal to less within double quotes evaluates to false. Okay, that's it. Next one, this time we are not using the word 1 variable, instead we are using the word 1 as an alphanumeric constant. So here we don't have this also is a constant, this also is a constant. So there is no reference to any of these variables. So we don't have to go to the variables in this case. We are just comparing these words. So you take this, and what we are saying is the word 1 is not equal to the word less. True. This is call word 1, this is less. They are not equal. Word 1 is not equal to less. We have alphanumeric constant called word 1. Okay, this is not variable. We are not referring to the word 1 variable here. We are just referring to the word 1. WORD1 is not equal to LESS. It's true. They are not same, no? If they are same, they are equal. If they are same, if you say not equal, then it will be false. But since they are not equal and we are saying it's not equal, this is true. The statement what we are saying here is true. That is, word 1 is not equal to the word less. Correct. That's what we are saying here. True. Next. Word 1 less than word 2. Now here there is no double quotes. So these two are, we are referring to this variable and this variable. So let's replace that. Word 1 is what? Word 1 is the word less. So this is actually we are referring to less in this case. Under this assumption we are referring to word 1 as the word less. Word 2 is the word greater. Okay, so we have the less than operator. So less than greater. Now don't look at the meaning. How do you compare alphanumeric? You take the first letter of this and the first letter of this and you compare first. If they are same only, you go to the next letter. But in this case they are not same. So and if you look at the ASCII values, G comes before the L. E, F, G, H, I, J, K, L. L has a higher ASCII value. So if you say L is less than G, it will be false. Because L has a higher value than ASCII value than the ASCII value of G. So when you say L is less than G in this case, because in alphanumeric comparison only first you compare the first two letters only. If they are same only, you go to the next two letters. But in this case they are different, so immediately you can say it is false because L has a higher ASCII value. So if you say this is less than greater, it's false. Why? Because L is bigger than greater, G. L has a bigger ASCII value than the value in G. Therefore, when you say L is less than G, it is false. L is actually higher. So that's why this becomes false. So word 1 less than word 2 evaluates to false. If we had said word 1 greater than word 2, then it would have been true because L has a higher ASCII value than the ASCII value of G. Okay, so that's V. Then we go to the next one where we concatenate word 1 and word 2. There is no double quotes here, so we are referring to these two alphanumeric variables, and then we are comparing with the letter Z, less. We are comparing it as less. So let's first concatenate these two. Word 1 is what? Word 1 contains less, so that is actually less. Word 2 contains greater, so that comes to greater. And then we have concatenate. And then we have less than Z. Okay, so now our expression is this. Now we have to concatenate these two. So less we join to the word greater, you will get a word called less greater. No spaces because there are no spaces in here or in here. So it just joins the two, less than Z. Now here again it's alphanumeric comparison, remember? So we are taking the first letter and comparing with the first letter of this. Anyway, this has only one letter. So L comes before Z, right? So L has a lower ASCII value than the Z. So when you say this one is less than Z or Z, it is true. Because this has a smaller ASCII value than this one. This is a bigger one. Therefore, L is less than Z is therefore true. Okay? So those are the ones with variables. When you have these values, if you assume these values as the contents of these variables, these expressions evaluates to these following answers. Okay, so that brings us to the end of your answers on this. We will meet you in the next video. Thank you very much.